Well, good afternoon, Strange Loop. We are a couple of hours away from the end of this conference, not the universe. I mean, I hear that all beautiful things must end. Otherwise, they are not beautiful. I saw this tweet from one of my favorite mathematicians, Steven Saltgrass. He was on a trip, and he said, I ran out of clothes on my trip, but it's all about the attitude. Then this morning, he shared this one. He said, now that I'm back from my trip, I've got access to my full wardrobe. And he was rocking this awesome t-shirt. It said, introverts unite. We are here. We are uncomfortable, and we want to go home. So for those of you who can relate, I mean, it was a blast. I enjoyed it a lot, but I'm definitely getting one of these t-shirts because I like going home as well. So for those of you who can relate, there is light at the end of the tunnel. So today we will be talking about what we learned, what my research team at Slim.AI has learned, dissecting the world's most popular containers. Now, I'm not a developer. I'm not a DevOps engineer. I'm a data scientist. And my interest in giving this talk to you is to provide a window into the world of containers as developers experience them, often for the first time. But before I go into the details of the research, I would like to give you a quick overview about us, who we are, why we do what we do, then give you a quick overview of the container landscape, how it is changing over time, talk about growth through a lens of opportunities, and then talk about the challenges that we are facing as an industry. Then we will go into, we will do a deeper dive into the research insights. And I would like to wrap it up with a focus on the future, how we can improve the status quo as an industry. Okay? But spoiler alert, we will be talking about a complicated, complex landscape. And from the data that I'm looking at, I can tell you this, it is not getting any simpler without us interfering. Can I see a show of hands? How many of you have heard about Docker Slim or Slim.AI before? Okay, a few. There is room for improvement. So Docker Slim is our open source container optimization, container hardening tool. It has been on GitHub for a while. It's pretty popular, about 15,000 stars, and thousands of teams across the globe have integrated it into their CI/CD systems. With Slim.AI, our SaaS platform, we are building upon this core technology. We are extending its capacity, making it easier to use, faster, more efficient, more secure. At Slim.AI, data is our central nervous system. We process thousands, hundreds of thousands of containers every day. It's a data scientist's dream, actually. And I get to be the lucky person who plays with data, all this type of data all the time, leads our analytical efforts in the company. My official title is I'm the Senior Director of Insights and Analytics. My background is I'm an engineer by training. I have spent quite some time in applied math and operations research. My grad work was focusing on physical supply chains. My thesis was focusing on technological forecasting. And after that, I spent some time in cybersecurity industry. And as the 2022 is being talked about as the year of software supply chain security, I use that background, which provides me a wide angle to look into data science problems like this. So about that data science background, these days, I'm getting a lot of LinkedIn connection requests. People are asking me about career advice on data science. I'm getting about 100 connection requests a day, and that is not my usual. normal rate by any means. So a couple of weeks ago, I learned that a video that I was part in got viral. I was at a conference 2 months ago, Open Source Summit in Austin. So that was the street interview. That was a crew that cornered me. So a cameraman, someone with a microphone. They said, can we ask a few questions? And I was late for my next talk, but they were so sweet, I couldn't say no. So they started asking me a few questions. They said, what's your job? What company you're working for? I told them that I'm working for this startup called Slim.AI. Then they said, how many hours do you work in a given day? And what is the good, the bad, and ugly of the job? So I answered, and then I walked away. I forgot about that interview. A couple of weeks ago, I started getting these connection requests, and people are telling me that there is this video that has been seen more than 1 million times on something called YouTube Shorts that I didn't know existed. And people are sending me questions, like, what is data science? What is your advice on me getting into this field? And I can't possibly answer all of these questions, but there is this one question that I keep getting over and over again. I love seeing that question. People ask me if data science is real science. And I respond to these questions when I get them. I say, of course not. One of my professors at MIT used to say, if a field has science in the name, it is not true science. Okay? Think neuroscience, decision science, computer science, data science, right? I never hear people talking about biology science or physics science or chemistry science, maybe because those fields do not have anything to compensate for. Joking, okay? But whether data science is true science or not, I don't think it takes anything away from the significance of the insights that I'm about to share with you today. So we'll be talking about the container landscape and those insights that we have seen in the data set that we have been looking into. But let's look into the industry at large, the landscape. So some of you will remember this graph from 2020. It's history at this point, right? The CNCF survey where they were trying to understand the adoption of containers. So you can see that from development to test to production, there is an undeniable increase in the adoption of containers, most notably in the production on your far right, that bar chart. That said, containers adoption in the production has increased from 23% to 84%. The only area that we are seeing a slight decrease in is POC, right? And that basically says containers are no longer just an idea. Companies are embracing these technologies. They're putting their trust into it, and they're using it in their user-facing web applications all the time. But that's yesterday's news. Containers have become the norm, they're mainstream. Let's fast forward to 2022, okay? So one of my favorite moments in the year is that time when Stack Overflow publishes that survey. I think it's a great way to feel the pulse of the development trends. There were 2 charts this year that has blown my mind. I don't know if you feel the same way. The first one talked about how Docker is the most loved technology among developers. I paused there because I don't know I don't know about you guys, but I have a lot of developer friends. They constantly complain, huff and puff about Docker, but they also have the same healthy disrespect for other tools that they use. There's this hate and love relationship. So I can wrap my head around that one. The second one said, Docker is the number 1 technology developers want to learn. And the second one, I believe, is Kubernetes in that graph. So combine that so you can start understanding why there's a huge influx of fresh blood into this cloud-native web application field. A lot of developers want to be in, which means that there's a lot of experimentation, exploration. As an industry, we climb up the learning curve, right? But if you remember at the very beginning, I said things are getting more and more complex, more complicated. So when we combine those things, right, new people experimenting, exploring, things are a lot more complex and getting more complicated. There's some tension there. There might be some challenges, right? So let's talk about Docker specifically a little bit more. So this is the place, this is the registry that houses more than half of world's containers, okay? Last time I checked, there are almost 1 million images, millions of developers across the world. And last year they said the number of all-time pulls on Docker Hub nearly tripled from 130 billion to 318 billion. Okay, and I'll pause there for a second because it took Docker 6 years to get to that first number, 130 billion. And in a year, it tripled. Okay? I don't use geometric or exponential when I describe growth lightly. But I think it's safe to say that we are using containers all the time, everywhere, across many software development projects in all verticals. Okay? The momentum has shifted. And while it is great that these atomic units that we are shipping, we're building and shipping our code in, right? They are giving us agility, more speed, efficiency. You guys will agree that container management is not trivial, right? Especially at scale. I mean, I have heard DevOps experts talking about how we are in the stone ages of container management, right? And I have seen it in small companies as well as large companies. So from experience, I know that things get out of control really fast. I also see it in the data, because since we founded the company back in 2020, we are looking into these containers, every new version, how things are changing over time. And my team is looking at these through a lens of like, if these containers are production ready, and if they are developer friendly, we try to understand the complexities under the hood, so we can see how things are getting more and more complicated. So for this specific talk, I would like to share this study that is very specific, where we looked at the most popular 130 public containers available. But as I said, we are cross-sectioning the data in multiple ways. We are looking into much larger data sets. But this is a spatial set that I'm going to be talking about. And the insights of this sample is important to understand for all of us in the industry. So I'm a data scientist, and I like to look into the methodology first, the mechanics of any study. So I wanted to go over some of these selection criteria, sample size issues. But if you have any questions later, I'm more than happy to answer. So in terms of selection, why we selected these, right? Why these 130? We looked at metrics that are popularity related. So we looked at pulls, likes. We also looked at the official Docker image status. We looked at, observed our own beta platform, the Slim.AI SaaS platform, and how people are scanning containers there. We also wanted to add a layer of qualitative insights. So we talked to container experts, container enthusiasts, and took in their feedback when we are creating the sample. I'm hoping that you're questioning the sample size. After all, that 130 might seem like a handful. It is small, especially because in a previous slide I said Docker has more than 9.5, almost 10 million images right now, right? But it is not small, and here is why. So if you look into these containers, some of them have been pulled 4, 5, 6, 7 billion times. In total, these containers account for more than 25% of all pulls, okay? Which, again, it is fair to say that a lot of people, new people especially, new developers going into Docker Hub, are pulling one of these images and starting. So these are the starting points of our modern software development process from a containers landscape, okay? So it's a very sizable sample in terms of usage. After selecting them, we curated them into 9 different categories. Some of these categories are more general purpose, others are special purpose. So I'm talking about things like web development and data science and programming languages in the general purpose ones. And in the special purpose ones, we looked at things like local development, DevOps, and infrastructure. We wanted to basically study the in-group, out-group dynamics of these different categories, try to understand if there are differences between these categories. In terms of process, we wanted to simulate a real-world scenario. We wanted to see what a developer would do going into Docker Hub, pulling one of these images, and then we scanned them using standard tools like X-ray from Docker Slim. All of them are open source, so you can go ahead and do it and replicate the study. We used SIFT from Encore for SBOM analysis, software bill of materials, and we used Gripe from Encore for vulnerabilities. And we basically did, what we did was we looked into the scan times of these containers, and then we deconstructed these reports into pieces and tried to understand what's under the hood. And I already talked about this, but the questions that we were trying to answer were things like, is this container going to be easy to use? Is it going to be efficient and safe? Will it cause any issues when I ship it to production? Okay. So let's talk about what we learned from this analysis. The first one is not the most surprising one, but I really wanted to validate this one. So bloated containers are a time sink for your CI/CD flows. We have seen a perfect correlation between the sizes of these containers and the time it took us to scan them, okay? Almost a linear relationship. So for every 50 megabits that we were adding, we were seeing 50 seconds, sorry, 500 to 50. So every 500 megabits result in an extra 50 seconds of scan time. Now that might seem trivial, right? If you're talking about a single container, a developer works with and deploys every once in a while, 50 seconds, not that important. But you guys know that scale changes the dynamic, right? If I ask you to buy me a pint of ice cream from the grocery shop like next hour, that's one task. But if I ask you to get me 20 million of them by next Monday without letting any of it melt, right? That's a different problem. So if we are talking about thousands of containers being deployed by hundreds of developers in an environment multiple times a day, those scan times add up. That's the first one, right? The second learning is one of complexity and how it might be hindering understanding even for the best, the wisest among us, the best DevOps experts. And there's a lot to unpack in this category. Like I brought in a couple of things, and I know it's very complicated right now. We are going to do a deeper dive. But I have seen a constellation, a group of charts where I was literally sitting in front of my computer looking at my screen with a blank face. I wasn't expecting what I was seeing at the time, okay? So I was expecting to see some outliers, but I wasn't expecting the averages being so high. So I was looking into the number of spatial permissions, licenses, libraries, packages, many things in these containers, because we were basically doing a lot of principal component analysis, trying to understand the contents of these containers. And for example, let's look into the packages piece. Like I was looking into different categories, like data science and web development. And some of these containers had 1,200, 1,100 packages in a single container. And you're looking at a box plot diagram here where you can see the median, the upper and lower quartiles, and the largest and the smallest outliers, okay? And the averages were like 300 packages, 400 packages in each category. I was planning to study the second order effects. So I was hoping to study the dependencies of these packages, because you guys know that there has been many studies looking into the dependency graphs. This one that I'm sharing here says, it's from Darmstadt University, 2019. They looked into a specific ecosystem, the NPM packages, and they said the package reach of the top 5 packages was between 134,000 and 166,000 other packages, making them an extremely attractive target for attackers. So 5 packages only, if you had them only, they would have, if there are no intersections, more than 500,000 other packages in their dependency trees. So I was hoping to look into this. But then when I saw containers having hundreds of packages, I realized that the tip of the iceberg was an iceberg. So there are so many packages already in them. So now, don't get me wrong. I'm not suggesting that these containers should not have any of these packages. On the opposite, I really think that it makes them a great playground. It makes things fun and experimental and easy for the developers. So you come in and you start using these without really questioning. But when it is time to ship these containers into production, if you're not making a conscious effort to remove the redundancies, right, you're incurring inevitable tech debt downstream. And there's a lot of issues, vulnerabilities that comes with that. I would like to talk about the vulnerability piece a lot longer, but we have limited time here. Because I'm always looking at these from the hacker's perspective as well. Like, remember, these are public containers. The things that I can see right now, they already know that, you know what, if they find one of these containers running in your production systems, they're already very familiar with what's inside them. So this third insight is looking into the vulnerabilities in these containers, right? And I will not be talking about the counts of vulnerabilities. You know, we know that attack surface is more than a vulnerability count, but it's important to know at least, you know, like what does the distribution looks like. But I have seen containers that had more than 2,000 vulnerabilities in them, okay? But the thing that shocked me, surprised me the most, was the severity distributions of these vulnerabilities, okay? So I was expecting to see less than 0.5% of these vulnerabilities belonging in a critical category, maybe less than 3%, 5 maximum belonging to a high category, but more than 20% of all vulnerabilities across all categories except base OS was, you know, the total of high and critical was 20%. And there were certain spatial case categories, like local development, for example, that I wouldn't expect to see this much severity. And in their cases, more than 40% of all the incidents belong to a high and critical category, which can be a blind spot for developers and DevOps people. Because general purpose containers, they're large, they tend to be a lot more experimental. But even those spatial purpose ones seem to be a huge attack surface for the organizations. Again, I can talk about that piece in a lot more detail, but we need to wrap this up. So the future. So this was our first step of this in-depth first phase of this in-depth container research. And what we found was a vast and varied and complicated landscape that offers a lot of opportunities to scale for developers, but it also presents significant risks, right? And as we collect more data, do deeper research with an action mindset, we will be able to answer questions that are vital. Like we will be able to start looking into the resilience of our software supply chains. We will understand the impact, the rippling effects on our technological ecosystem. But in the end game, what's our purpose, right? What do we want? We want our developers to have the best experience possible. We don't want them to feel like they are behind, that they need a PhD in infrastructure. We don't want them to feel like they're running an unending marathon without a finish line. Like I'm a runner. I can face a lot of adversity, but if I don't know that there is a finish line, I can't continue, period. We want them to have fun. Developers, experimenting, exploring, that's all great. But we also want safe and efficient production systems. We want to ship production-ready containers to production. And to me, there is only one way of doing that. We need to automate the optimization of these containers. Okay. I mean, if you learned anything from decades of studying complex systems through system dynamics, systems thinking, we know that complex systems are inherently riskier. And as you can see, as an industry, we haven't spent enough time for intelligent simplification yet. And I know that I sound very pessimistic. I'm not. I know that the future is bright because I know that there are teams across the globe. My team at Slim.AI, we are losing our sleep over solving this problem. And when we put our minds together, we can achieve great things. So that's why I'm hopeful, and next time I speak here, I'm going to be bringing better news. With that, thank you so much. I would love to continue the conversation. Let's connect on Twitter, LinkedIn. I'm not going to give any career advice on data science. But thank you so much for having me. If you have any questions, feel free to ask. Thank you. I mean, software is a living structure. It changes all the time. It's a living organism. And there's this snowball thing that happens all the time. Everything is being updated. Your security teams are asking for the latest packages all the time, the latest versions. I know that developers are like, don't update anything. Things are working. But security teams feel very uncomfortable when they see a package that is not going to be fixed going forward, and there is a new version and it is not in there. So those things are happening all the time. There's that dynamism, that change that we need to embrace, and which basically needs a lot of maintenance on our ends. We can start with the base OS, but if you're not an expert, a DevOps expert, starting with a bare metal environment, a container that has nothing in it, and then you add everything that's needed. I have seen people doing that, manually creating their containers and then putting that into their workflows. But it's for the newer developers or for anyone who doesn't want to start with the bare bones, that's not the easiest way. So yes, if you can, those base OS containers seem to be a normalization. So how many times these things are being used? Okay, I've waited. I have done that analysis. Good thing that you asked. So I have we have been working on so many different cross sections of this data. And there is a talk that's coming up. I'll be a keynote speaker at KubeCon North America in a couple of weeks, and we have a new paper coming up. We have a ton of insights with different angles. That's something that we also looked at. I don't know if we will publish it, but let's continue conversing because that's an area that I'm interested in exploring more. Okay? for all of these images, we have the base OS, the Debian, all of that information built in. Most of them were, like Debian was the most popular distro, as far as I remember, and I have a chart showcasing what they look like. We didn't include that in the analysis, but is the question, could there be a correlation between that and the scan time?
Yeah, the question was, given the same...
Again, good question. I hope you guys continue this conversation with me, because we can explore that. We haven't looked at that, but we can explore if there's anything interesting with that. Go ahead.
Sort of on that, you mentioned...
There were different ones. For each and every one of them, we collected that information. It wasn't a single distro. There were multiple. But it was, I think we had 5, 6 of them. So it wasn't a huge donut chart of different things. But if the question is about looking at these containers in these, we looked into them through that category analysis. That was the in-group, out-group dynamics that I mentioned. But we haven't combined them into groups. We were looking at them in isolation, which is basically a magnifying lens. These things do not work in isolation. For every microservice, you have a lot of them working together, and you need to be looking at the system dynamics of this, right? Even at that atomic level, that an individual level in isolation, there is a lot of complexity. The moment that you add these things together, the problem becomes extremely complex. But I would love to do that. I would love to look into, I'm already looking into the dependency analysis of these packages for the second report. But yeah, those are interesting questions. I keep saying interesting, great. Go ahead.
Do you have any theory or...
I'm not pointing any fingers. You said that. I think we have a lot of work to do. I'm going to put it that way. There are a lot of maintainers. Some of them are communities, volunteer work. All the problems that we have with open source, I guess, might apply here. Especially because with that lens of how 130 containers are accounting for 25% of everything, should we pay more attention to these? Because again, there's an influx of new developers who might not understand all the complexities involved. I think as an industry, we have work to do. I'll leave it there. One last question, go ahead.
How did the survey methodology evolve?
The latest. So for this study, again, I was trying to, I asked the team to look at this from different angles, but we said, we didn't oversimplify for this study. We have done other oversimplified examples. But for this study, we said, we are going to only take the latest ones. But then, because we have been collecting data since 2020, 2019, actually, we can see that version history, how things are changing. And that's the topic of a talk that I'm about to give in 4 weeks, which is not that KubeCon keynote. But I'm looking at the life cycle of these vulnerabilities, how things are changing from, maybe we can still look at the latest, but during a time series, and I'm seeing things are not improving as well as I expected. So great questions, guys. Thank you so much. Again, please feel free to add me on LinkedIn, Twitter, and ask questions. I would love to continue the conversation. Thank you.